So we're on section 5-3, negative and zero exponents. So negative exponents, when you look at them, all of a sudden you'll think, oh, these are so hard and I don't get it, Miss V, and what am I going to do? And really, when we get down to it, they're really not that bad. So let's actually start with the zero, anything to the zero power. And let's start with the ones that we know, actually. Let's start with these. These are nice and easy. So 2 to the first power would just be 2. 2 to the second power means 2 times 2, which would just be 4. 2 to the third power, now I'm multiplying this answer by 2, which means that I'm getting 8. So let's see if we see the pattern of what's happening every time. 2 to the fourth is 16, and 2 to the fifth would be 32. So every time I increase that power by 1, I'm doubling my answer. I went from 2 to 4 to 8 to 16 to 32. So it's doubling every time. So now let's use that same pattern, but go back the other direction. So let's say I have 2 to the 0 power. Well, what is half of 2? And half of 2 would be 1. So anything to the 0 power always equals 1. 4 to the 0 power is 1. Negative 3 to the 0 power equals 1. X, Y, Z, all to the 0 power equals 1. Happy face to the 0 power equals 1. All of it equals 1. Always. So let's keep that pattern going. So now, can we continue this pattern? So I went 4, 3, 2, 1, 0. So in theory, we should be able to go 2 to the negative first. So 2, oops, let me fix that. 2 to the negative first. Well, what is half of 1? And that would be 1/2. If we have 2 to the negative 2, half of a half is a fourth, right? And let's even go one more than that. 2 to the negative 3, half of 1/4. I have to take 4 pieces and I have to cut them all in half. Now I have 8 pieces. So half of 1/4 is 1/8. So what's really going on is that you are changing the location, essentially, of that base. So when you see a negative exponent, I want you to think that it moves to the opposite location. So if it began on the top of the fraction, it goes to the bottom and vice versa. So really 2 to the negative second, actually let's just do 2 to the negative 1 just for ease. So 2 is the same thing as 2 over 1 to the negative 1. So this tells us to flip that fraction over, and it's going to equal 1/2 to the positive 1. So it flips. There's 2 things that go on. It flips, right? And then that exponent becomes positive. So somewhere in your notes, over here to the side, you can write that negative exponents means you take the reciprocal, and then change exponent to positive. Okay, oops, positive. There you go. Okay, so let's just do a couple of examples down here. So let's just pick 4 random ones. So let's do 7 to the negative third. So 7 is the same thing as 7 over 1, and it's currently, if we really think about it, sitting in the numerator part of the fraction. Let's just take that out of there. That if I do that, and I change the location, now it's going to go on the bottom, and that exponent is going to become positive. And I could multiply that out if I wanted to, and it would be the same thing as, this is also raised to that power. So it'd be 1 times 1 times 1, which is 1, over. And if we wanted to multiply that out, 7 times 7 is 49, times another 7 would be 343. So what happens is you're going from a base of 7, but you're taking the third root of it each time, which is making it become really small. Okay? So it's changing in size also when you have negative exponents. So it's changing location and it's changing size, going from really large to really small, or really small to really large. So let's have x to the negative 4th. So that is the same as 1 over x to the 4th. Okay. Then let's go with negative 5 to the negative 4th. So that would be 1 over negative 5. This negative doesn't change because that applies to the coefficient, not to the exponent. Applies to our base. But that would become to the negative, or sorry, to the positive 4th. Negative 5 to the 4th. So that would be the same as 1 over 625. Okay, finally, let's have 3y to the negative 3. Okay, so what you have to be careful of is still, even though it's a negative exponent, this exponent only applies to what's directly in front of it unless there are parentheses involved. But there are no parentheses involved, so this negative 3 only applies to the y. So one way you can think of it is what's going to stay and what's going to go. That 3 of the coefficient is fine. Nothing's changing that, so it's going to stay on top of that fraction. The y, because it's got a negative exponent, is going to change locations. It's going to drop to the bottom, and its exponent is going to become positive. And your answer would be 3 over y cubed. All right, let's go on down here and let's rewrite some now using only positive exponents. Okay, so I'm going to draw a fraction line and just decide what needs to stay and what needs to go. If something has a positive exponent, it can stay. If it's got a negative exponent, it's going to move, and that exponent's going to become positive. So we'll have the 2 will stay on top because it's positive. It doesn't change. X squared has a positive exponent. That's going to stay on top. The y has a negative exponent. It's got negative 3. So it's going to move to the bottom and become a positive 3. And then the z I've got on the top, and it's got a positive 2, so it can stay right where it's at. Okay? All right. Let's go over here. Same thing. Draw your new fraction line. 1/4 is just its own fraction, so the 1's going to stay on the top and the 4 is going to stay on the bottom. The a has got a negative exponent, so that's going to drop to the bottom, change locations. Ooh, what did I do wrong? There we go. Let's get that out of there, Miss V. You can yell at me if you'd like to. That's fine. Okay, that's going to change to a positive exponent. The b is already a positive exponent, so it's just going to stay right where it is. C to the negative 3, that's a negative exponent, so again, it's going to change location and become positive 3. So your answer will be 1b to the 5th over 4a squared c to the 3rd. All right, moving on. So let's deal with one thing at a time. So we know with GEMDAS, we need to deal with parentheses and exponents first. So I'm actually going to multiply each of my powers first and kind of get a simplified fraction going on here. So we know that 3 is the same thing as 3 to the 1st. So now we're going to use our distributive property and multiply each of those exponents. When we have a power to a power, we multiply the exponents. So our base is 3, and my exponent is 1 times 2, which gives me 2. Negative 3 times 2 is negative 6, and 0 times 2 is just 0. Now I'm going to draw my fraction line. 3 squared is 9. That's going to stay on top. I've got an x to the negative 6, which means it's going to change location, come downstairs, and change to a positive 6. And y to the 0, what's anything to the 0 power? Don't say 0. Anything to the 0 power is just 1. So really we could put a times 1 up here, but we know that 9 times 1 is just 9, so we really don't need to do that. So it would be a little cleaner just to have the 9 there. And your answer would be 9 over x to the 6th. Okay, last one. Oh my goodness, what's going on here? So, again, start a fraction line. I like to deal with coefficients first. So 2 times 3 is 6. I'm going to put that on top. Now let's use all of our rules that we've got. So we know when we have the same base and we're multiplying, we can just add these exponents together for the m's. So 4 minus 3 is just 1. Well, that's kind of nice because m to the first is just m. And then we have n to the first. Remember, if there's no exponent, it's understood to be a 1. N to the first minus n to the fifth would be n to the negative 4. Now I know that that's got to travel downstairs and become positive. So what I get as a result is 6m over n to the fourth. Okay. So there's all your notes for the first section of 5-3. And now we'll go on to the second page of 5-3. All right, just a couple on this page. So let's see what we've got going on here. So now you're going to kind of use all of your rules that you know. So you can simplify these one at a time, or I'll show you another kind of cool trick to do this. So do your coefficients first. 4 divided by 2 is just 2. Now, I like to move my exponents first. Anything that's positive is going to stay right where it's at. So x squared is going to stay there, x to the fifth, y squared, z fourth can all stay where they are. This is my little problem guy in here. Right there in the spirit of Star Wars being such a big thing right now. This is the problem, that y to the negative third. So I'm going to move him downstairs and make it positive. Now I can just kind of total up what I've got. So I've got a 2 on top. Now let's look at our x's. I have more on the bottom than I do on the top, and I have more by 3. So I'm going to have x to the third on the bottom. On the bottom also, I've got 2 y's over here and 3 y's over there. So on the bottom I have y to the fifth. And then again on the bottom, one more for good measure, I have z to the fourth. And that is as far as you can simplify that. Okay. Before we go down to that really wicked one at the bottom, let's do one more of those. I'll make one up. Let's see. 3 over 18 a to the negative 3b squared, c to the negative 4 over a squared, b to just b, how about just b, and c to the sixth. So let's just kind of simplify those one at a time. So anything that's got a negative exponent is going to move. Anything that has a positive exponent is going to stay. So first thing we can do is simplify that fraction that we've got going on here. Let's see. Let's pick a different lightsaber this time. Let's pick a red one. There we go. Ooh, there we go. So negative 3 over 18. Now remember, this negative on the coefficient is just the value of that. It has nothing to do with the exponent, because this is really negative 3 to the first power. So that negative is going to stay there. Negative 3 over 18 reduces to negative 1 over 6. Okay, so we're fine with that. Now, anything that's got a negative exponent is going to move, change locations, and become positive. So the first thing that's going to go is that a to the negative 3. B squared is fine, b is fine. C to the negative fourth is not okay. So it's going to move downstairs and become positive. Now you can just ask yourself the question, where do you have more A's, B's, and C's? So let's start with the A's. I only have A's on the bottom, and I have 5 of them. B's, I've got 2 on the top and 1 on the bottom, so I have 1 more on the top than I do the bottom. So that'd be b to the first. You can either put the b there or not put the b there. And then finally, I have all of these C's on the bottom. I got 6 plus 4, which gives me 10. And that is simplified. All right, let's do the last. Go back and make sure you got that answer. Let's do the last one. Now it's kind of combining all of our exponent rules that we've got going on. So let's kind of help ourselves out and add in exponents. You may not need these, and if you don't, that's fantastic, but some still will. And until you're really positive about all of this, I want you to make sure that you've got them. So remember, this is 2 to the first, x to the first, y to the fourth. Anywhere you don't have an exponent for now, I'd like you to add in a 1 just to make sure that you don't miss it. Now we can we can multiply each of these exponents here. We've got a power on the outside, which means that we need to multiply each power by that exponent of 3. So let's kind of start one at a time. So I've got 2 to the first times 3, so that would be 2 to the third, x, and that's to the first times 3, which would be x to the third, and then y to the fourth to the third power, which would be 4 times 3, which is 12. Now that whole thing is simplified, but it's got to get multiplied by 3x to the negative third y to the second over 4x to the negative third. Well, y to the 0, what do you know that y to the 0 equals? Anytime you have y to the 0, it equals 1. So we can really just kind of eliminate him. We don't really need to deal with him right now. All right, so let's get things kind of simplified here. Let's move this up a little bit. So let's deal with our coefficients first, because those are the easiest. So 2 to the third is 8. And 8 times 3 would give us 24. And we have a 4 on the bottom. So now when I've got, here I kind of lucked out because in my x's, I've got an x to the negative 3 on the top and on the bottom. So those in fact can cancel out. And those will go away. And we will only have this x to the third left. When I deal with exponents or any large equation, I tend to like to cross things out as I go to make sure I've kind of covered it all. Then the other thing I've got is I've got y's here. I've got y to the 12th and y to the second. I know I can just add those exponents. So I have y to the 14th. Now everything's kind of good here. The only thing I have to do is reduce my fraction here, and then I am done. So 24 divided by 4 is 6, x to the third, y to the 14th. Okay, good. Nice short section. 5-4 will be next, and it's the last one. Thanks.